Quiz 1 review, graphing systems of equations. So the first question asks, what are 3 types of solutions to a system of linear equations? So this is just more of a review thing, but you will be asked to show understanding of this on the quiz tomorrow as well. So there's blank graphs and a blank space for you to identify the 3 different types of solutions. They don't need to be in any particular order, but the first and most common type of solution would be a single point, or a, one, why is it not writing? 1 point, and it would be the point like x comma y. And you might have a line, let's say, starts here, slope of 2. Just sketch out this line. Okay, so that could be line number 1, and line number 2 could be like this, going through the origin, and let's say it has a slope of -1/2. 2. Okay, that's the second line. These lines have, so the purple line, any dot on this line is a solution to the purple line, and any dot on this pink line is a solution to the equation of the pink line. And so if we're talking about systems and how these are working together, I'm trying to identify what is a solution to both. Well, there's only one point that includes both of these lines, and it's the point where they intersect right here. So that's not a very nice point because it's not on a corner, but you would just write that as a coordinate, x comma y. So the next type of solution that we could have is no solution. And you can express that by writing this, and okay, so no solution would be 2 parallel lines. So I could have a line with the intercept at 1, and let's just keep it simple, a slope of 1, so up 1 over 1. So this is the first line. And I could have another line that has a different intercept, so maybe say -1, 2, 3, and same slope, because that's what makes lines parallel, is they have the same slope. Okay, these lines are parallel, meaning they have the same slope. They're never going to intersect one another. Okay, I have people requesting to be in the live, and I don't know what that means. So if you can let me know, I don't know what you want to do or what that means. So I don't know, send a message and I will let you in if I know what that means. Okay, so no solution. Parallel lines have no solution. Okay, and the final option would be infinite solutions. And sometimes that's expressed with this infinity symbol. And so infinite solutions is a case where you have a line, let's say have an intercept of 2 and a slope of 1/3, up 1 over 3, down 1 over, okay, this line right here. And I graph another line, and it just so happens to be the exact same line with the intercept at 2 and a slope of 1/3. These lines have all points in common. Every single point is going to be a solution to both equations. So we have infinite number of solutions here. Okay, someone asked, is this exact question going to be on the test? Not this exact question, but you will be expected to provide examples of a 1-point no solution and infinite solutions situation. Where you're kind of making up the graph or the equation. So just make sure you know how to do that and what they look like. Okay, moving on to this next section, it says, determine whether the system has no solution, 1 solution, or infinitely many solutions. If the system has only 1 solution, name it. So there will be 2 like this on the quiz tomorrow where I'm giving you the graphs and you are going to tell me what the solution is. So this first one is the case of parallel lines. They are non-intersecting. And so if I'm asking myself what points do they have in common, the answer is none. This is no solution. The second one, we have two lines and they intersect at this point right here. So so there's one solution, and that specific solution is 12. That's my x value, comma, and then my y value. If I look over here, be careful, my scale is counting by twos, so it's -12, -14, -16, and this is right in between the 14 and the 16. So my y value would be -15, except I just realized I wrote x instead of what I was actually supposed to write, which is 12. So it's 12, comma, -15, and that's the solution there. And then this one, all I see is a single line, so that means that any point on this line would be a solution, and it goes forever in both directions, so there are infinitely many solutions. All right, so moving on, there's a word problem here. I believe I gave every class some tips about this because this one did take me a moment to figure out how to scale the graph, so I think I gave everyone some tips about that, but I'm just going to read through and walk through how to solve this. Olivia is considering two phone plans. Plan A charges $20 per month plus, that's 5 cents per minute. And then Plan B charges $15 per month plus 10 cents per minute. And then it's asking how many minutes can Olivia talk so that both plans will cost the same amount. So each of these plans, we can write an equation to represent them. So for Plan A, the money that she's going to spend, I can represent by y. The total money she's going to spend is equal to this $20 per month. $20. She's going to pay $20 a month no matter what. Plus, each month she's also going to pay 5 cents per minute. So I can write that as a decimal for now. And that's per minute, so times however many minutes she is talking. So I'm going to represent minutes by x. Okay, so this is Plan A. She's going to pay $20 plus 5 cents per minute. Plan B is a little different. The total money she's going to pay for Plan B would be $15 per month, so it's a lower flat rate, but she's going to pay a little bit more per minute. So she's going to actually pay 10 cents per minute. So it's asking how many minutes can Olivia talk so that both plans will cost the same amount. Meaning, obviously this plan looks cheaper on the front end, but if she talks too much, this one's going to get expensive faster than this one. So we're going to graph these lines, and that point of intersection should tell me, it should answer this question. So I'm going to go to talk about the scale of this graph. So when I first did this, let's first look at what these slopes are. So these are in the form, my mx is over here, mx plus b. This is my intercept. And then this is mx plus b. So the first thing is these slopes look a little funny because they're decimals. So I want to think about these in terms of fractions of how much I'm going to be going up and over. So 0.05 is 5 out of 100. 5 out of 100, which can be simplified to 1 over 20. So this is really 1 over 20. So I'm going to be going up 1 and over 20. So if I'm thinking about scale, for every 1 I'm going up, I'm going to go over 20, which is quite a lot. So my graph is going to have a tendency to be really wide and stretched out. And this is the issue I had the other night. And same with this one. This is 1 out of 10. This slope. So I'm going to go up 1 over 10. So similarly, I'm going to have to go up 1 and then over 10. So my graph is going to be really stretched out. So I'm going to want to use different values or count by different things for the scale on each axis to make this work. Also keep in mind, for my intercepts, my y-axis has to go up at least this tall, if not taller, because I'm going to be moving higher. So I have to cover quite a bit of ground. But also my slope is only going up 1 at a time. So the way I counted for this was, and I want to move this out of the way. Okay, and I want to decide y is total money. So I'm going to put that over here. The total cost per month And then that depends on how many minutes you're talking. So minutes is going to go down here. So the total cost, in order to make this work, I would need to count by ones because my slope is only going to be going up one at a time. But I can't fit everything on there counting by ones and get up that high. So I'm going to use this little symbol to show that I'm going to kind of shortcut, and I'm going to start at 15 because I'm starting at 15 and I'm going up. So I really shouldn't need anything less than that. So I'm going to start at 15 and then I'm going to count by ones. 16, 17, 18, 19, 20. 21, 22, 23, 24, 25, 26, 27, 28, 29, 30. So that should be good. And then on this axis, since for my slope I need to be able to go up 1 and over 20, I don't want to go up and then, whoa, way off the graph. I have to be able to stay on the graph. So I'm actually going to count by tens on my x-axis here. So I'm going to go 10, 20, and I am skipping lines in between, but this should still be fine. 30, 40, 50, 60, 70, 80, 90, 100. Okay, so that's how I would recommend setting up the graph, and I discovered this by trial and error. I tried a couple different scales, and then I realized this one works pretty well. So, because I want to see my point of intersection. If my point of intersection isn't going to happen until way off the graph, then I'm not going to be able to find my answer using this method. So I can just go ahead and graph these. So this is mx plus b, so 20 is my starting point, which is right here, and my slope is up 1 over 20. So once again, being careful of my scale, this is going by 1, so I can go up 1, but 20 over here is just over 1, 2, 3, 4 grid spaces. So I'm going to go up 1 over 1, 2, 3, 4, and that's equal to over 20. And I'm going to continue that pattern. Up 1 over, I'm really counting by fives here. Up 1 over 5, 10, 15, 20. Up 1 over 5, 10, 15, 20. And up 1 over 5, 10, 15, 20. So that is phone plan A. Okay, moving on to phone plan B. Phone plan B has a starting rate of $15, so that goes here on 15. And then it is increasing, okay, it's increasing by up 1 over 10. So I'm going to go up 1 over 5, 10, up 1 over 5, 10, up 1, 5, 10, up 1, 5, 10, up 5, 10, up 5, 10. Okay, it's going to take me a little bit. Almost there. And finally, just in time, we have a point of intersection. So this point right here is showing the point, the amount of minutes, which if I look down is 100, the amount of minutes you have to talk for these phone plans to equal the same amount. Because this plan, the purple plan, it's starting more expensive, but its slope is not as steep because you're paying less per minute. The plan B, or the pink plan, is starting on 15 and it costs more per minute, so the slope is steeper. So after this point, after you talk 100 minutes, this pink plan is actually going to be more expensive. Sorry, the pink plan is more expensive and the purple plan will be less expensive. So in real life situation, if you are a big talker and you're going to talk a lot, then the purple plan would be best. But if you're not going to use that many minutes talking, then the pink plan is probably the better plan. All right, so that is the first page of the quiz review, and I'm going to move on to the second page. Okay. So this is the part where we are actually going to do the graphing, and we are going to find the solutions ourselves. So here we go. Step 1, if you look back to the very front of your packet, it goes through the steps. So step 1 is to put the equations in slope-intercept form so you can identify M and B. And then step 2 is going to be graph each equation. Step 3, look for the solution, which will be the point of intersection, or possibly no solution or infinite solutions. So I'm just going to get to work. By now, if you are not comfortable solving for y or getting it by itself, you really need to work on that because we need to be very comfortable with that strategy. So getting y by itself, I'm going to move x out of the way. I'm left with a negative y equals negative x plus 3. Y is still not alone. It has a negative in front, so I'm going to multiply or divide everything by negative 1, which will change the sign of everything. So now I can see that my slope is 1 and my intercept is negative 3. Before I even deal with the second equation, I'm going to go ahead and graph this one. I think some people are getting confused and then their graphs get messed up. So I'm going to solve for m and b and go ahead and graph it right away. So negative 3 is here. Slope of 1 is up. It's positive, so it's going up 1 over 1, like this. We are still getting very confused with positive and negative slopes. Do whatever you need to do to remember. If it's positive, it goes up. If it's negative, it goes down. That's probably the biggest issue I see. All right, now that this line is graphed, I'm just going to get this one. So I'm going to subtract the x. I'm left with negative 2y equals negative x plus 3. I'm going to divide everything by negative 2. I'm left with y equals, I've got negative x over negative 2. That becomes a positive 1/2 x. 3 over negative 2 is negative 3/2. Some people were thrown off by this because my intercept is a fraction, but it's still okay. Oh, back up. It's okay for it to be a fraction. So I'm going to go ahead and plot that. Negative 3/2 is the same as negative 1/2. So I'm going to start at negative 1/2, which is halfway between the lines. And then I just want to be careful with my slope. If I'm going up, I'm staying halfway. I'm going over 2. Haven't intersected yet. Up 1 over 2. Neither of these are points of intersection, but once I draw this blue line in, I can see that they intersect right here at the x-intercept. So the solution to this one is over 1, 2, 3, 3, 0. That kind of looks like a negative. It's positive 3, 0, because I'm going to the right. All right, next one. Need to solve for y. I'm going to subtract x from both sides. I'm left with 2y equals negative x plus 4. Divide everything by 2. I get y equals, this is a negative 1x over 2, so negative 1/2 x. 4 divided by 2 is 2. So my slope is negative 1/2. My intercept is 2. I'm going to go ahead and take care of this one before I even look at the next one. 2 is up here. Be careful, this is a negative 1/2, so it's going down. Down 1 over 2, down 1 over 2, up over 2 this way. Draw that line. Okay, my second line is already in slope-intercept form. That's nice. So I'm just going to highlight my slope and my intercept. My intercept is at 2. And my slope is also down 1 over 2. Look at this. This is one of those situations where the lines are exactly the same. So my solution is infinite solutions. Any point on this line is going to be a solution. All right, next one. This one's already in slope-intercept, which is nice. So I've got my slope, my intercept. Intercept at 3. Slope of 2, it's going up 2 over 1, and then continue the pattern this way. There it is. Okay, my next line is not in slope-intercept. I just need to divide everything by 3. So I get y equals 6 divided by 3 is 2, x, and then negative 6 divided by 3 is negative 2. So my slope is 2 and my intercept is negative 2. I'm going to go ahead and graph negative 2. Slope of positive 2 means this line is going up 2 over 1, up 2 over 1. Okay, these lines look parallel, and if I check their slopes, they both have a slope of 2. They are parallel. So that means they're never going to touch each other. The solution is no solution. Moving on to this next one, number 7. Okay, need to get y by itself. I'm going to subtract 3x from both sides. I get negative y equals negative 3x minus 2, divide everything by negative 1, and I get y equals negative 3 divided by negative 1 is positive 3, negative 2 divided by negative 1 is positive 2. So my slope is 3, my intercept is 2. I'm going to go ahead and graph that. Intercept at 2, a slope of 3 is going up 3 over 1, which is off the graph. If I continue that pattern, I'm going down 3 over 1, down 3 over 1. My second line, need to solve for y, so I'm going to subtract 3x. I get negative y equals negative 3x plus 0. Divide everything by negative 1. And I get y equals 3x plus 0. So my slope is 3, my intercept is 0. It's going through the origin. And up 3 over 1. Down 3 over 1. These lines also look parallel. If I check the slopes, a slope of 3, a slope of 3, they are parallel. So the solution is no solution. They will never touch each other. Okay, next one. This y is already by itself, which is nice. My slope is 2. My intercept is negative 3. I'm going to go ahead and graph it. Negative 3 is down here. A slope of 2 is going up 2 over 1. There it is. And my next line, I do need to solve for y. People who I was working with this on in class were having trouble getting y by itself because the y is actually on the right. I still want to get everything away from the y, so I'm going to subtract 6 first. And I'm going to go ahead and flip this when I rewrite it. I'm going to put the 2y on this side and set it equal to 4x minus 6. Then I divide everything by 2. And there we have y by itself. So 4 divided by 2 is 2. X, negative 6 divided by 2 is negative 3. M and B, I'm going to start on negative 3 and go up 2 over 1. Looks like we have the same line. And sure enough, 2x minus 3, 2x minus 3. These have all points in common, so the solutions are infinite. Okay, this is the last one. Need to get y by itself. Move the x over. Divide by 2. I get y equals, this is like a negative 1 half x plus 3 over 2. This is another funky one where my intercept is going to be in between two lines. So 3 over 2 is 1.5. So it's right, 1.5 is right here. So when I go down 1 over 2, I'm going to stay in between the lines. So that is my first line. And my second line, need to solve for y. That's a negative y equals negative 3x minus 5. I'm going to multiply everything by negative 1, flip the signs, makes everything positive. So my M and B is at 5. There's an issue with this graph. Obviously, it doesn't go up to 5. 1, 2, 3, you're off the graph, so I'm just going to draw it in up here. And then a slope of 3 would go up even more and over this way, so I need to go, when I go back down, I want to head this way. So down to 3 over 1, 1, 2, 3 over 1, and I can already see that I intersect right there. That's my point, and that point is negative 1, comma, 1, 2. All right, so that is it for our quiz review.